Download this code from codegive.com, link in the description below. Understanding Explain Analyze in PostgreSQL, a deep dive. Explain Analyze is a powerful tool in PostgreSQL for understanding and optimizing query performance. It not only shows you the execution plan, like explain, but also executes the query and collects statistics on the actual execution. This allows you to see how the query actually performed, including the real cost, row counts, and timing information for each step in the plan. It's essential for pinpointing bottlenecks and making informed decisions about indexing, query rewriting, and configuration adjustments. This tutorial will cover the following. 1. What is an execution plan? 2. Basic explain. 3. Introducing Explain Analyze. 4. Understanding the output of Explain Analyze. Plan tree structure. Cost and time metrics. Row estimates versus actual rows. Buffers and shared hit/read. 5. Interpreting and utilizing Explain Analyze output. Identifying problem areas. Indexing strategies. Query rewriting techniques. 6. Advanced Explain Analyze options. Analyze verbose. Analyze buffers. Analyze settings. Analyze format. 7. Common Explain Analyze scenarios and solutions. 8. Limitations and considerations. 9. Code examples throughout. 1. What is an execution plan? Before diving into Explain Analyze, it's crucial to understand what an execution plan is. The execution plan is a representation of the steps the PostgreSQL query planner will take to execute your SQL query. The query planner's job is to choose the most efficient strategy based on available statistics, indexes, and the query itself. It's a tree-like structure where the top node represents the final result and the leaf nodes represent the data access methods, example table scans, index scans. Each node in the tree represents an operation, example filtering, joining, sorting. 2. Basic explain. The explain command provides the estimated execution plan without actually running the query. It allows you to preview the plan chosen by the planner. Example asterisk. First, let's create a sample table and populate it with some data. Now, let's use explain to see the estimated plan for a simple query. The output might look something like this. The exact output will vary depending on your PostgreSQL version and data. *sec scan on users. This indicates that the planner expects to perform a sequential scan, reading every row, of the user's table. *cost equals 0.001.27, this represents the estimated cost of the operation. The first number, 0.00, is the startup cost, the cost to get the first row, and the second number, 1.27, is the total cost of the operation. These costs are relative units, not absolute time measurements. *rows equals 10, the estimated number of rows the planner expects to be returned by this operation. *width equals 183, the estimated average width, in bytes, of the rows returned. *filter, age 30, this indicates that a filter will be applied to the rows to only return those where age is greater than 30. 3. Introducing Explain Analyze. Explain Analyze goes a step further. It executes the query and provides actual execution statistics. This gives you much more accurate information about how the query performed. Example asterisk. The output will be longer and more detailed. A simplified example is shown below. Again, the exact output will vary. Notice the added actual time, rows, and loops information. Let's break down the key differences. 4. Understanding the output of explain analyze. The output of explain analyze is presented as a tree, similar to the output of explain. Each node in the tree represents an operation performed by the query. The output includes plan tree structure represents the order of operations. Read the plan from the bottom up, leaf nodes to root node. Cost and time metrics cost equals 0.001.27, estimated cost, same as explain. Actual time equals 0.015 0.028, actual execution time in milliseconds. The first number is the time to return the first row, and the second number is the total time to complete the operation. Row estimates versus actual rows rows equals 10, estimated number of rows, same as explain. Rows equals 12 loops equals 1, actual number of rows returned by the operation and the number of times the operation was executed, usually 1 for most simple queries. In this example, the planner estimated 10 rows but actually found 12. Large discrepancies indicate that the planner's estimates are inaccurate, often due to outdated statistics or complex data distributions. Rows removed by filter, 8, this is specific to the filter operation. It shows how many rows were discarded by the filter condition. Buffers and shared hit/read, when using explain analyze buffers. Buffers, shared hit equals 2, indicates how many data blocks were found in the shared buffer cache, hit, and how many had to be read from disk, read. Shared hit means the data was already in memory, making access faster. Shared read means the data had to be retrieved from disk, which is much slower. Lowering the shared read count is a primary goal for query optimization. 5. Interpreting and utilizing explain analyze output. The real value of explain analyze lies in its ability to help you identify performance bottlenecks and guide optimization efforts. Here's how to use it. Identifying problem areas high actual time values nodes with significantly high actual time values compared to other nodes are prime candidates for optimization. Large discrepancies between estimated and actual rows indicate inaccurate planner estimates. Run analyze on the table to update statistics. If the problem persists, consider more sophisticated statistics options, like create statistics. Sequential scans sequential scans on large tables are often performance killers. Consider adding indexes to support the query's where clause. Shared read in buffers high shared read counts indicate that data is being fetched from disk. Ensure sufficient RAM is allocated to postgresql's shared_buffers setting to improve caching. Indexing strategies if a query is performing a sequential scan instead of using an index, it could mean no index exists on the column s used in the where clause. The planner estimates that a sequential scan is cheaper than using an index, example if the query selects a large percentage of the table's rows. The index is not selective enough, example a Boolean column with mostly true values. Create indexes on columns frequently used in where clauses, join conditions, and order by clauses. Example The output might now show an index scan instead of a sec scan, and the execution time should be significantly reduced. Query rewriting techniques avoid select only select the columns you need. This reduces the amount of data that needs to be read and transferred. Use appropriate where clause conditions use the most selective conditions first. Asterisk optimize join conditions. Asterisk ensure that join columns are indexed and that the join conditions are correctly written. Asterisk consider using with clauses, common table expressions, CTEs to break down complex queries into smaller, more manageable parts. Sometimes this can help the planner find a better plan. Asterisk use case statements carefully. Asterisk overuse can hinder the planner. Example asterisk. Let's say you have a query that is slow because it uses a function in the where clause that prevents index usage. Instead, you can rewrite the query to avoid using the function in the where clause, if possible. Or, add a functional index that stores the lowercase emails. 6. Advanced Explain Analyze Options. Explain Analyze supports several options to provide more detailed information. Asterisk Explain Analyze Verbose. Asterisk includes additional information, such as data types and internal names, making the output more detailed and potentially easier to debug. Asterisk Explain Analyze Buffers. Asterisk shows information about buffer usage, shared hit/read counts, as described earlier. This is crucial for understanding whether data is being read from memory or disk. Asterisk Explain Analyze Settings. Asterisk shows the values of relevant configuration parameters, example work_mem, effective_cache_size, that might affect query planning and execution. Asterisk Explain Analyze Format. Asterisk specifies the output format. Options include text, the default, JSON, XML, and YAML. These formats can be useful for parsing the output programmatically. This will output a JSON representation of the execution plan, which is useful for automated analysis. 7. Common Explain Analyze Scenarios and Solutions. Here are some common performance problems you might encounter and how Explain Analyze can help you solve them. Asterisk slow queries with full table scans. Asterisk. Asterisk problem. Asterisk the query is reading the entire table, even though it only needs a small subset of the rows. Asterisk Explain Analyze output. Asterisk shows a seq scan on a large table. High actual time for the sequential scan. Asterisk solution. Asterisk. Asterisk create an index on the column S, used in the where clause. Asterisk if the query is selecting a large percentage of the rows, a sequential scan might be the best approach. Consider if the table is too large and if archiving older data might help. Asterisk ensure the table statistics are up to date with Analyze. Asterisk slow queries with nested loop joins. Asterisk. Asterisk problem. Asterisk nested loop joins can be very inefficient, especially for large tables. They repeatedly iterate over the inner table for each row in the outer table. Asterisk Explain Analyze output. Asterisk shows a nested loop join node with high actual time and potentially a large number of loops. Asterisk solution. Asterisk. Asterisk ensure that the join columns are indexed on both tables. Asterisk consider rewriting the query to use a different join type, example hash join, merge join. PostgreSQL will typically choose the best join type based on statistics, but you can influence the planner using set enable _* parameters, use with caution. Asterisk ensure work_mem is sufficiently high to allow for hash joins and merge joins to spill to disk. Asterisk slow queries with sorting. Asterisk. Asterisk problem. Asterisk sorting can be expensive, especially for large result sets. Asterisk Explain Analyze output. Asterisk shows a sort node with high actual time. Asterisk solution. Asterisk. Asterisk if possible, avoid sorting altogether, example by retrieving data in the desired order from the application. Asterisk if sorting is necessary, ensure there's an index that matches the order by clause. Asterisk increase the work_mem configuration parameter to allow more sorting to happen in memory. If the sort spills to disk, performance will degrade dramatically. Asterisk queries that spend a lot of time in planning time asterisk. Asterisk problem asterisk the query planner is taking a long time to come up with an execution plan. Asterisk explain analyze output asterisk shows a high planning time. Asterisk solution asterisk. Asterisk simplify the query if possible. Complex queries with many joins and subqueries can be difficult for the planner. Asterisk ensure that the statistics are up to date using analyze. Asterisk reduce the value of geco_threshold. This setting controls the number of tables in a query before the genetic query optimizer, GEQO, is used. GEQO can take longer to plan but sometimes produces better plans for very complex queries. Turning it off for simpler queries might speed up planning. Asterisk consider using prepared statements for queries that are executed repeatedly. 8. Limitations and considerations. Asterisk overhead asterisk explain analyze executes the query, so it will consume resources and potentially modify data, if the query is an insert, update, or delete statement. Be cautious when using it on production systems, especially during peak hours. Asterisk statistics dependence asterisk the accuracy of the execution plan and the statistics it provides depends on the accuracy of the table statistics. Regularly run analyze to keep the statistics up to date. Asterisk parameter sensitivity asterisk the execution plan can change depending on the values of parameters used in the query. If you have parameterized queries, run explain analyze with different parameter values to see how the plan changes. This is also called parameter sniffing. Asterisk non-deterministic functions asterisk if your query uses non-deterministic functions, example random, now, the execution plan might be different each time you run explain analyze. This can make it difficult to compare results and identify performance issues. Asterisk concurrent activity asterisk concurrent database activity can affect the actual time values reported by explain analyze. Ideally, run it on a system with minimal load to get more accurate results. 9. Conclusion. Explain analyze is an invaluable tool for PostgreSQL query optimization. By understanding the execution plan, analyzing the actual execution statistics, and applying indexing and query rewriting techniques, you can significantly improve the performance of your database applications. Remember to regularly run analyze to keep statistics up to date and to be cautious when using explain analyze on production systems due to the overhead of executing the query. Experiment with different explain analyze options to gain a deeper understanding of how your queries are performing and how you can optimize them.